Okay, so for LDM for LDM3D SR, it basically specializes in super resolution. So like utilizes the same autoencoder for LDM3D and but now it can encode like low resolution images. So first it encodes low resolution images into like 64 by 64 by 4 dimensional latent space, and then here the unit model is like modified into like having an 8-channel input. So this change like enables like conditioning or LR latent via concatenation to the high resolution latent during training. So like this also facilitates like text conditioning across using cross attention. If we use a clip text encoder, so we fine tune the unit in LDM3D from SD Super S, and the training data consists of HR and LR sets with 261,000 samples each. So for HR samples, we use a subset of Lion aesthetics 6 plus with tuples, and for LR images, they are generated using a lightweight BSR image degradation method. So mm, I'm not actually sure like why it would or wouldn't work. Like, yes, if anyone knows, like they can elaborate. Bhavya. Yeah, yes, we can talk about it after the paper discussion. So, yep. So now we have just like explored like 3 methods for generating LR depth maps. So first one is like performing depth estimation on the LR depth maps, and then utilizing the original HR depth map for the LR conditioning, and then like applying bicubic degradation to the depth map. So let's come to the results. So first I'll yes. Yep. All right. Let's come to the results of the high resolution RGB generation. So basically, we evaluated HR RGBD generation using a subset from ImageNet, and it composed of 20 to 43 samples at 512 by 512 resolution. The LR validation set is constructed by a bicubic downscaling of HR RGBD, and let's come to the image evaluation first. So in line with the previous studies, we used like reconstruction FID, IS, peak signal to noise ratio, and like structural similarity index measure to evaluate the quality of the images. So like these are like summarized in this table as we can see. So yep, FID, which basically is like Freshet inception distance, and in IS is inception score. So as we can see, our model has like the least
RGB upscaling or RGB upscaling?
RGBD scale, right?
But then how do you validate that from ImageNet? So, sorry, because ImageNet doesn't have that. So
Maybe it doesn't like.
but do you like find that somehow?
No.
Yeah, I just I don't know how these are evaluated. That sounds very painful. Yeah. But maybe that's possible. That's not doable though. Yeah.
Yep. So yeah, and so our findings reveal that the for the image evaluation of the R model. So like LDM3D SR achieves like the best FID and like the second best IS after like SGX4 model, as we can see in the table. So
So, how do you do it?
hmm,
Oh, okay, I didn't I'm clear on the evaluation, but so you have like RGB. So probably you don't understand, but you have like RGBD images, and then you are trying to upscale them. But like, do the RGBD images also have texture? If
they
that's
don't.
the case, then you cannot like validate
No,
it.
they don't have texture.
So if you have
I don't know. I'm not sure.
but like but we are you shouldn't you have like some texture and some physics simulation as well for shadow design, light transport. But because if that's the case, like you can't evaluate it this way.
Yeah, I mean, maybe because they didn't talk much about that aspect of the RGBD. So yeah, and also like one thing we can observe is conversely, bicubic regression attains like the highest scores on PSNR and SSIM. These are like similar models to our LDM3D, and like yeah. So let's now look at the depth evaluation of our model. So for the depth evaluation, as I think we can also look at the pictures of our output. So as we look at our LDM3D's photo, we see that the lion's eyes and like facial features are like very high resolution compared to the others, especially for like the previous LDM. And
is that like an interpolation of the RGBD or is that like just RGB example?
it's it's this one or like this one? Okay.
Is that like one view from the RGBD without?
It's the output of the model, right? So basically we input the LR input, and after the encoding it's the value. So LR input is basically what we input into this model.
And that also has like depth map with it, but it's not just being shown here.
Yes, yes.
Okay.
It's just a qualitative comparison.
But so the output also has a depth map, right? That's what I'm.
Yeah, it should.
Oh, okay. And
See, I think, yeah, this photo summarizes everything, I think. We can see the depth maps.
what's punch?
Uh, I don't know. I think I'll just Google it. Yeah. Hmm. Maybe. I mean,
Against, yeah, there it is again. Against my implementation.
so yeah, it mentions it right here. I think bicubic degradation. Yeah, I mean, we can discuss about it later, I guess. I'll just complete the results and then we can like discuss everything. So,
If you actually see like the panorama results, so you can see about items.
hmm,
Yeah. Oh no, the ones which were. Oh yeah, those. Okay. I mean like because it seems like these are also yeah, these are also not diverse. It's just repeating stuff. And yeah, that will be.
hmm, hmm,
But then, so if you get like this image, that's like a stretched image, right? So yeah, how does it like still get repeated by super resolution though? Because like the earlier super resolution results seemed a bit different from these.
I think they increase the input size of the unit, right? Now it has 8 encoders and decoders. All right, then, Bhavya will continue the results for Panorama.
So mainly they use like the Frechet inception distance and the inception score for clip similarity. Uh, so in short, like the LMD3D pano, LDM3D pano outperforms the textilite LDR in panoramic depth perception, achieving like a lower mean relative error, which is better compared to like the baseline model. Uh, Despite having like a higher Frechet inception distance, uh, despite having like a higher Frechet inception distance, like LDM 3D panel like demonstrates a diverse image generation capabilities with like slightly higher inception score and clip similarity. So it does generate like images like with a like in diverse images like generation capabilities like better than previous models. But I don't think it still generates like a in efficient way, but it still generates better than the previous models. So that's one way to look at it.
What's the check mark colors here?
This one?
No, the is it yeah, what is the check mark color signify? That's what I got is uh, are they showing it seems they're showing like red for closer distances, but
Yeah.
sometimes it does something completely different?
No, I think like based on like all these, it does like look like the red for closer distance. As you can see, like the base is like closer comparatively, and in this one the ground is comparatively a bit red. So
Assuming these are like also cherry picking and then they don't seem good if you just see like the first image.
this one,
Yeah, if you just see like the first these are cherry picked anyway.
yeah,
It doesn't seem like decent.
yeah, but like they claim that it like the results are a bit better than the previous model, so like it's better, but not sure if it's like a very efficient tool in regarding to that, but like as you can see in this image also, it's kind of a bit iffy images, but like it's not better compared to earlier papers. So like I'm not sure in this paper if they have the images for that, but give me one sec. Not really, but like in like the previous papers that they mentioned, like the textulate paper, these images are definitely better than those papers. Like if you want, I can pull them. Hold on. It's fine. But like maybe they're better than the textulite and the previous papers mentioned here. That's it. Like in short, it is without even like FID is like it helps you measure like how good the image is related to the related to real images. So even though like it is a bit worse, like the lower that is the better it is. I think it is better. So even though it is a bit higher than the text to light one, we can still like it's hmm, it's better in a sense like one sec. It is better because the text to light is not very diverse. As you said, like these images don't look very diverse, but compared to like the text light is not at all diverse. It is very specifically trained for specific objects, the textulate paper. So they claim here that it is more diverse than the textulate paper. So that is why the higher FID might not be as much of a problem because they're more diverse in that category. Do you want to do the conclusion?
So they successfully introduced LDM3D panorama and LDM3D super resolution for like VR applications. And then like panorama competes with the like specialized models by like generating diverse high quality panoramic images with like really good panoramic depth, and SR focuses on RGBD upscaling and like it outperforms any like upscaling methods. So yeah, basically that's it. Thank you for joining for our paper discussion. We don't have any pizzas because no one registered. Yeah. Follow us on Discord, Instagram. Keep posted on our future paper discussions.
So it does like 360 views, but it's not really like 3D, right? Yes. You still need like the other novel views. So, so I don't, so I probably don't understand it very well. How do you even put it for a VR videos? It's not like 3D objects. I don't know. It just seems like it's a 360 view.
During training, is it shrinking the image at all, or learn to see the larger before making it into a panorama, or is it just relating the image as a
I honestly don't know.
It's just like with the latent space, right? So
what doesn't seem
yeah, yeah. It was not very detailed. Yeah. Currently, there's have like in space, maybe that's interesting to try. Sorry. Oh, no, but it should generate like the equation probably. We can see how well that is. I was wondering if they can do like chip specific generation because yeah, can you like generate around an object or is that like harder for these kind of models? The smallest build, but then I guess like I'm trying to understand if you can like generate more views of a single object or generate like a 360 view of a single object instead of this, I guess. I think tomorrow is the last day for application and then